Hi there, folks. Today we're looking at graphing polynomial functions, and really this is kind of an extension of what we've already done in terms of graphing. We've drawn quick sketches of these things where we identified, the x-intercepts and the kind of the path that the function follows. We're going to do that same kind of thing here, but we're going to use graphing calculators and computer programs to kind of fill in the gaps to make these a little bit more of an accurate representation of the graph, all right? So yeah, we're going to start with this idea of, okay, what does this thing kind of look like? What is it supposed to look like? And then we're going to use the calculator to give us a more accurate depiction of that path of the function, of the shape of the function. And then we're going to identify all the important points on the function, all right? And this is slightly different than the way we've graphed a lot of other things, because instead of having like, exact values marked out on our graph, okay, because some of these values get really big or really small, all right, we're just going to draw kind of a model of this thing where we label the important points but don't necessarily count to them, okay? And you kind of see what I mean as we go through this. It'll be slightly different. We won't have like the little tick marks on our graph, but we'll still label those things using ordered pairs to show the accuracy, to show exactly where this thing kind of goes to, all right? For example, if I look at this first one, so kind of looking at this from the approach of what we already know, in terms of drawing a quick sketch of this thing, what we already know how to do is when it's in factored form like this, we can easily find the x-intercepts, all right? The computer or the graphing calculator will also be able to do that for us, but a lot of times it's easier to do by hand when it's in this format. So we say, hey, if this thing equals 0, let's find the x-intercepts. I've set each of these factors equal to 0. And I solve each here. This one I would add the 1. Here I would add the 3. And here I would subtract the 2. So I get these ordered pairs, 1, 0, 3, 0, and negative 2, 0. And then from here, I'm not going to draw on my graph off to the side over here. I'm just going to draw a quick sketch maybe over here, an unofficial kind of sketch. And so if I kind of look at this unofficial sketch, I've got, let's see, a 1, a 3, and a 2 here. I also kind of know about the path of this function by looking at the end behavior. And so when I look at the end behavior on this one, remember, I only want the first term of this thing multiplied out, so I only multiply out the first terms, okay? And each of these binomials to the first power, so it's just x times x times x, which is x cubed. So if I were to multiply this out, I would get a 1x cubed. And again, if I continued to multiply out all three of those binomials, which I can do, I would end up with a 1x cubed and a bunch of other terms. But again, I only care about the first one if I want to know the end behavior. And so an odd degree on this one, if the degree is odd and the leading coefficient is a positive, it means that this end is going to go down and this end is going to go up. Okay? And then based on how many times I got each of these answers, because each of those binomials only occurs once, I get each of those answers only once, which means in terms of multiplicity, the path has to be something that kind of goes like this. Okay? And I know it's supposed to look kind of like that. Now, there might be some details in there that I'm missing, so maybe it could do something like this. It's possible that it kind of goes like this, and then it has like an inflection and does all kinds of stuff like that. For this particular example, it's not going to do that, all right? But there might be some details that we don't know about that'll kind of appear as we graph this thing using some of our graphing utilities and that kind of thing, our calculators and the Desmos is the other one that we'll use, okay? And so we have this idea of a quick sketch. That'll help us when we look at the calculator or when we look at the computer to make sure I find all those important values. See, right away, I can see there's a relative maximum between the negative 2 and the positive 1. There's a relative minimum between the positive 1 and the positive 3, okay? So let's go look at the graph of this actual thing. All right, so using Desmos here, we're just going to punch this guy in, and you can do the f of x the way it's written. Desmos will recognize that, or you could just punch in it as a y. Either way, it's the same thing. So let's see, we had f of x equals, and it was an x minus 1, and you can see right now it's a line. As we punch in more degrees, we get different functions. So there's our x squared function, and now we'll move on to the x cubed by punching in the last guy. And so when you look at this thing, we can see pretty much the whole graph. There's only a little piece of it missing. but it looks pretty much like the quick sketch we had drawn. And so to see this whole thing, I might have to move around a little bit. There we go. And maybe, the other thing we might have to do, depending on how stretched out this thing is, we go up to this little gear, and we can make minor adjustments here. Like I can tell it, I don't need to see all of these x values. I only need to see something like negative 5 to maybe positive 5 or something like that, okay? Always give it a little extra space. We don't want to cut this thing close. Oops. And then the y values look pretty good. The other thing I like to do is I always like to change it to a step of 1 for each of these so that I can see all of the x values and all the y values. I also like to turn off the minor grid because it looks cluttered to me. But again, as long as you can read everything, we can now see this thing in a little bit more in a more accurate way. And so we'll draw this sketch in a slightly more accurate way. We'll draw it as best we can just to depict the shape of this thing. And then to get these critical points in Desmos, you just have to make sure that you click on the function. Okay? And once this function is selected, you can see that it automatically highlights in gray, little gray dots, all of the critical values. So you just have to go here and here's the x-intercepts, -2, +1, and +3. We already had those, and that's okay. Here's the y-intercept, 0, 6. So we write that guy down. Let me jot it down. And then this guy, right here, the relative maximum, -0.786, comma 8.209. So I write that guy down. And then I got to jot down this last one. Let me scroll over to this last one. So again, if I just hover over it, once the line is selected, it'll should display these as I hover over. So 2.12 and a -4.061. Okay, so I write all those values down, and then I head back over and sketch my graph to show the shape of this thing and plot all of these points and label them to give the thing a little bit more accuracy. So let me head back over. And so from the graphing utility, here's what we've got. We looked at this and saw that, the graph our sketch wasn't too bad. It does go up like this and then comes back down and then back up again. Okay, so our kind of quick sketch was good. We can make it a little bit nicer as we draw this thing. So now I'm translating that. And again, we draw the quick sketch just to kind of give us an idea of the shape of this thing. And then to show all of these different pieces, we're just going to label them. So like here, I'm going to label this. And instead of having these little tick marks all drawn, I'm just going to label this ordered pair -2, 0. And if I do the rest of the x-intercepts here, let's see, that's 1, 0. This one was the 3, 0. And again, we already knew these even before we looked at the actual graph. But what the actual graph then gave us was these guys. It gave us this relative maximum here, and that was the ordered pair -0.786, comma 8.209. And then down here, this relative minimum. Again, we got a 2.12, -4.061. Okay, and so we kind of copied all those things down from the graph, and now we put them on here. And again, the graph isn't completely accurate in terms of I didn't draw all the little tick marks and kind of show this thing around 8.2 for that first relative maximum. I show the accuracy by writing an ordered pair. Okay, so I draw a sketch that gives me an idea of the shape of this thing, and then I give it accuracy and I give it more context by including all of these really special points and showing exactly where those things are. Okay, and so even if this thing isn't necessarily drawn to scale in terms of the actual curve and in terms of the relationship between the x and the y axis and how far apart those little tick marks are and that kind of stuff, that's okay, because I still have an idea of the accuracy of this thing based on the ordered pairs that I have written down. Okay, and you can even tell in this drawing right here from this relative maximum down to the axis, that's 8 units, and here, that's -4. Really, if I was drawing this to scale, that -4 should probably be up here somewhere, okay? But again, we understand that this is just giving us the shape. The accuracy is based on the values I have written. So we're not necessarily drawing it to scale. We want a good representation of this thing, okay? If I look at this next one, same kind of thing, except this time I don't have this thing in my factored form. I could factor it, all right? So I could try factoring it and finding the x-intercepts and that kind of stuff. But really, we don't need to do that. We just need to understand, okay, an x to the fourth function, I kind of have an idea of what that might look like. So if, again, I only look at the first value here, I already know the end behavior. And just based on our knowledge of some of these other things that I've dealt with, if I know the end behavior, so even degree, so they're both going to open up or down, since the leading coefficient is positive, both ends are going to open up. So I know both ends are going to open up, and just knowing what I know about these different functions, well, this thing might do something like this, okay? Or maybe it crosses the axis more times, it might do something more like this, okay? Or it could do something like this. So again, I have a general idea of what this thing looks like or what it could look like, but now I'm going to use the graph to kind of get a little bit more detail on those things, okay? So I'm going to punch this in, I'm going to find all the important values, including the x-intercepts, and then I'm going to draw a more accurate depiction of this thing, okay? So back over here in Desmos, I've reset the graph for Desmos here just so we can work on manipulating the graph again. But once again, I punched this thing in. So let's see, it was f of x this time equals. And this time I want to do an x to the fourth. And if you hit the x, if you use the little caret button, which is like shift 6, it'll automatically go up into an exponent for you. You can also come down here to the little keyboard, and there's like the little exponent buttons that you can use as well, okay? But again, if you use the little caret button, minus 4x raised to the third power. And make sure you hit the over key after you do an exponent so it comes back down, plus 2. And so as we look at this thing, none of the versions I had in terms of my quick sketch looked exactly like this. I can see that I do have that first curve. It just doesn't kind of have the depth. It doesn't give me a relative maximum. And then I have a much deeper curve the second time. And I can't see the bottom of this thing. So, as I start to scroll around, there's the bottom of it. I could try zooming out. And what happens as I zoom out, this thing kind of gets really pointy. It doesn't even look like a curve anymore. So I really want to adjust the window, and this is where I have to go back to that little gearbox, and I have to say, okay, looking at the x values, I don't need too much in terms of x. It's the y values that are really causing me an issue. So I'm going to go -5 to +5, which I think is similar to what I did last time. The x values here now look good. The y values look fine. I'm going to change the step once again. I'm going to change it to a step of 1, and I'm going to get rid of the minor axis because, frankly, I don't need it. And so as I look at this thing, here's my graph. And so I have a semi-accurate depiction of what this thing looks like. I'll be able to go over and draw a quick sketch of this thing that relatively displays the shape. Now I just need these special points. So again, I click on the graph, and there they are. I just have to hover over them. There's my y-intercept of 0, 2, so I write that guy down. And then I'll do the x-intercept. So let me look at the next x-intercept. It's 0.86, 0. So I write that guy down. This one, 3.968, 0. So I write that guy down. And now last, I'll look at this relative minimum that's down here. And it looks like 3, -25. Okay? And that's an exact value, which is surprising. But, these things don't always work out nicely. Sometimes we have weird values for the relative maximums and minimums. Sometimes we have them for the x-intercepts, okay? But the graph gives us that accurate depiction of where all these critical values are, okay? So now I'm going to hop back over. I'm going to draw my picture. I'm going to label all the points so that I have a graph that displays the shape and displays some of the accuracy and some of the context by identifying these ordered pairs. And so from the graph, I found out that, my quick sketch here wasn't exactly right. Instead of having 2 relative minimums, I only had 1. The function did still have more turning points, but it kind of went like this. It kind of came down this way, and then curved that way, and then curved back down, and then back up. Okay? And so I still get more curvatures, but this guy wasn't extended out as much as we thought it was going to be. Instead of this thing going like this and then coming back up and down, it kind of just curved like it was going to start back up, but then went down instead. Okay? And so again, we knew where to look for that thing. We knew to look somewhere towards that left-hand side, that there was going to be some kind of curve we needed to mimic. Well, it just didn't end up being exactly the way we thought it would be. Okay, and then from the graphing device, we just calculated or found all of these values. So we had this guy that was at 20. Sorry, I looked at the wrong note that I had. This one was 0.86, comma 0. This other x-intercept over here was 3.97. I rounded it off just a little bit, comma 0. And then the relative minimum down here, that was a 3, negative 25. Okay? And so the only value that surprisingly came out nicely was that relative minimum. The x-intercepts, we wouldn't have been able to find those by factoring, so the calculator, the computer really helped us out on that one, okay? So now, again, even though this thing isn't drawn to scale, if it was drawn to scale, this relative minimum would be way, way, way down here, probably even further down than that. But instead of having this huge graph, I condense it a little bit. I don't quite draw it to scale, but I draw an accurate representation or an accurate enough representation of the shape, and then I add accuracy to it, I add context to it by labeling all of those special points, okay? If I look at this one, this is one where I can get a little bit more information before I graph it. So once again, I could set this equal to 0 because it's in factored form, and I could find the x-intercepts ahead of time. Okay, so if I set each factor equal to 0, here I get x equals 0, so that's the ordered pair 0, 0. Here I would add the 6 and get x equals 6. That's the ordered pair 6, 0. But then there's also something special here. Because of this guy, because there's an x to the first out here, I'm going to get that answer once. That's multiplicity. But look at this. Because there's an x squared here, it means I would get this answer twice. Okay? And so that idea of multiplicity gives us a little bit more information about the sketch of the graph here. Again, looking at just the leading coefficient and the degree, if I were to multiply out these things, so that would be just the first terms, so this guy squared is an x squared, and then times the negative 2x. And so, again, just looking at those first terms, again, if this guy was squared, it would be an x squared, and then times just this first term. So I just look at all the first terms and I multiply it out. That gives me the first term of the overall polynomial. It's a 2. Reading is hard sometimes, right? A negative 2x to the third, okay? And again, if I were to completely multiply this thing out, which I could do x minus 6 times itself, multiply all that out, then distribute the negative 2x. If I did that, I would end up with a negative 2x cubed and a bunch of other values. But again, I don't care about those values. I just wanted the first one. And so because it's a cubed function, it's an odd function with a negative leading coefficient, I know that this end is going to go up and this end is going to go down. Okay? I also know these intercepts here, this guy and this guy. And I know a little bit more about this because as this thing comes down here, and let me move this guy over a little bit. As I approach this first value, I'm going to go through the x-axis because the multiplicity is odd. But right here, this one I'm only going to touch the x-axis. And that has to deal with this guy right here. That idea of multiplicity, remember that when multiplicity is odd, it tells me to keep going through the axis. Okay? But when the multiplicity is even, it tells me to do a relative maximum or relative minimum at that point. It tells me to just touch the thing. Okay? And so the end behavior all matches up. I kind of have an idea what this graph looks like, but now let's go get a more accurate representation. Okay? All right, so this one, once again, I've reset my graph. And I punch this in, f of x equals, it's going to be a negative 2x, and then x minus 6. Close my parentheses and square it. Again, I could just use the little caret button and then the 2. And so once again, this thing kind of looks like gibberish, all right? This doesn't look anything like what I was expecting, but it just means that I'm not looking at it right. I have to zoom out. I have to change where I'm looking and find those pieces so that it does represent the depiction that I assumed it was going to. And so I just start by kind of zooming way out here. Now I can see this thing, and I look at it and go, okay, this is really condensed. I can see how low this thing goes, And so I'm going to go over to my gearbox, little wrench that's over here. And again, I don't need a whole lot of width in terms of the x values. So I'm going to go maybe like the -5 and the maybe a +15 or something here. And there we go. Now I can see the whole thing. Again, I like to change these. You don't have to change these. It doesn't hurt anything to leave it the way it was. But now I can kind of see this thing. And it does look the way I was expecting it to look. It just didn't look like that at first, okay? I had to kind of change my zoom. So I click on it. I hover over those critical values. 0, 0. I already knew that one, but that's okay. Here, this guy, 6, 0. I already knew that, but that's okay. But notice it's confirmed that's a relative maximum. The only one that I really need to find now is this guy at 2, -64, okay? And again, you know, when I draw the sketch of this thing, when I draw my version of the graph, I'm not going to count all the way down to 64. That would be ridiculous. We draw a sketch that shows the shape. I show how truly far down this goes, how large this curve is by labeling the ordered pair. Okay, it wouldn't be realistic to draw graphs that were this big and mark all these points. So we draw a sketch that models the shape, and then we label all these critical points. Okay, so let's head back over. And so for this one, I found out that my graph wasn't in too bad a shape. I have these values here, but in terms of the shape, this thing comes pretty steeply down. And then back up and down again, okay? And so we get this this slightly more accurate representation. The thing that really makes it accurate, though, is all the values that I got from the graph. And so right here, this was the ordered pair 0, 0. Again, I already knew that one. This one was the ordered pair 6, 0. But then I also was able to pick up this relative minimum at 2, -64, okay? And so again, I have a sketch that represents the shape of the graph. I have all these points that represent the accuracy of the graph and all those special points that I need, okay? And not only that, but now I can see the relative maximums, the relative minimums. I would be able to interpret this in a little bit of a better way, okay? If I look at this one, once again, I could try to solve this thing by factoring, but let's let the calculator do the work for us. Now that we have a better idea of what these things kind of look like, again, maybe I look at the end behavior on this one because I've got a 1/4 x to the 4th. Again, I only look at this first value. I don't care about the rest of them written. I know it's only one other one, but I just look at this guy and say, hey, the degree is 4, so an even degree, they're both going to either open up or down both ends, and because the leading coefficient is positive, I know that both ends are going to open up. So right away, just thinking about the quick sketch of the graph, both ends open up. And again, I don't know about the details. Maybe this thing goes like this, okay? Maybe this thing goes like this. Maybe it does one of these things, all right? Maybe it does one of the things that it did before where this thing kind of curves this way and does something like this, okay? Well, we know that it's going to be something in that vein, but we're going to get a more accurate representation by graphing this thing using a calculator, using the computer, okay? So let's go take a look at the graph this time. And so once again, with this one, we punch it in. I've reset my graph one more time. And if you just hit the little slash button when you type this in, 1/4, it'll automatically go in as a fraction for us. And then again, hit the over so you're not in the denominator anymore. X to the 4th, and then a -2x to the 2nd. Okay? And once again, Desmos does the work for us here. This one I don't really need to adjust at all. I mean, I could zoom in if I wanted to see the points a little bit better, that kind of thing. But again, this one, the values are fairly small. So I click on it, x-intercept, let's see, a -2.828. And it looks like this is symmetrical. It'll come over here, yeah, +2.828. So this one is perfectly symmetrical. I've got 0, 0 in the center. So again, I write each of these x-intercepts down. This x-intercept is also the y-intercept. And then I get these relative minimums here, -2, -4. I'm assuming the other one is 2, -4. And it sure is, okay? So this thing is perfectly symmetrical. I write down all those values. And now again, I'm going to go draw the sketch that shows me the shape. and I'm going to make it accurate. I'm going to depict the accuracy by labeling all of those critical points, okay? And so after looking at the graph, I found that this thing was perfectly symmetrical. And so I had something that kind of looked like this, where I had one end that went like that, and then a second end that did the exact same thing, okay? And everything was symmetrical as I labeled these values. So like the x-intercepts, this guy was at negative 2.828, comma 0. The other one over here was at a positive 2.828, comma 0. Of course, this guy in the middle, that's at 0, 0. And then I identified these relative minimums, and those were also symmetrical. This one was at negative 2, negative 4. And this one was at positive 2, negative 4. Okay? So again, I get the shape of this thing. I draw a quick sketch that represents what this thing should look like, but then I give it accuracy, I give it context by labeling all of those crucial points, okay? Relative maximums, relative minimums, x-intercepts, y-intercepts, okay?